Welcome to the sixth and last part of What's New in Autodesk Inventor 2017, a deep dive into new functionality. I'm Andreas Ernst Wagner and I work as a designated support specialist at Autodesk. Topic for the last chapter are the interoperability enhancements. In other words, what did we improve in Inventor for a better collaboration with other data formats? Introduced in Inventor 2016, we further improved the associative insertion of an AutoCAD DWG file in an Inventor port file as a DWG underlay. You can now include DWG underlays in your drawings you've been already using in Inventor models. You can use the included geometry to add text and dimension for annotation purposes. You should know that the AutoCAD layer styles and line types are imported into the drawing file as well. Use the Style and Standards editor to manage those imported AutoCAD layers and line types. Please keep in mind DWG underlays are associative. That means changes made to the DWG file itself by using AutoCAD, for example, lead to changes in the DWG consuming Inventor file, but associatively updates the Inventor drawing file. Additionally, you can crop a DWG underlay to improve performance and remove unwanted data in part files. Cropping allows you to focus on the relevant design area when you are working with a large DWG file. In the Inventor assembly environment, you can add constraints and joints to cropped underlays as well, and use such geometry to combine 2D DWG underlays with 3D model geometry. As I'm personally convinced of the DWG underlay technology, I've prepared a complete workflow for you. Let's begin with the referencing of a DWG file into an Inventor part file. Click on the import command and select an AutoCAD DWG file you'd like to use as DWG underlay. Define in the next step a work plane and a work point to place the DWG geometry. No worries about this message. It only tells you that the inserting of an AutoCAD DWG creates an associative DWG underlay. This is exactly what we want. If the DWG geometry is changed, the Inventor IPT should also be updated. The second hint is about the use of the project DWG geometry command. You can make underlay geometry A available in a sketch and B associative by projecting underlay geometry. So you can start to build your model features based on projected DWG underlay geometry, which is also associative to the origin DWG file at the same time. Okay, back to the new crop functionality. The DWG underlay displays the same content as in the DWG model area as available. Everything came across independently if you need the geometry or not. My shaft example contains a section view I don't need for my design purpose. Right mouse click on the DWG underlay record in the Inventor model browser and select crop. As you may know, the crop command keeps geometry you've selected, so I select the view is intended to be included in my future design. I'm now going to create a new Inventor assembly and to use the crop DWG underlay geometry. At first, I place the IPT containing the DWG underlay into the IAM. In the second step, I add another port is intended to function as design change. Why am I doing the design change with Inventor and not in AutoCAD? There is a simple answer. For a long time, the design department changed from 2D to 3D. The most designs are already available in 3D Inventor models, like our newly added port. So the effort to keep the legacy design up to date in AutoCAD is more expensive than to manage the design change in Inventor file format. By the way, the design department immensely benefits from the streamlined 3D design process to third-party vendors or from the generative design capabilities. Back again to our crop DWG geometry. You have seen I'm easily able to use crop DWG geometry to constrain components to each other. In the last step, we take a look at the drawing environment. As usual, I'm creating a base view at first. In this case, I needed to derive a section view for a better technical communication. Yes, the DWG Underlay geometry is still invisible. You need to navigate through the drawing view browser and move to the view the DWG Underlay geometry should be displayed. In my case, the section view is the right one. Right mouse click on the DWG record and include the geometry. I quickly need to clean up my drawing views as only the section view is interesting for me. Let's test some annotations are now applicable to crop DWG underlays. The dimensions were great. On top, a leader text to show additional details. Lastly, a look into the Style and Standards editor. Under the Layers node, you can see the AutoCAD layers were imported during the DWG underlay. If required, you can adjust the setting for line type, line weight, etc. The location of a DWG underlay now associatively updates when the location of the DWG underlays plane and/or insertion point changes. For example, if you place a DWG underlay on a corner of a model and then change the location of this corner, also the location of the DWG underlay updates associatively. To make underlay placements associative, you must select one of the following points as the insertion point when placing a DWG underlay. I've got a sheet metal model here. The sketch point I'm zooming in shall be used as insertion point for the strap to show the support for the associative placement. The strap geometry is only available in AutoCAD DWG format and shall be made usable with the DWG underlay technology. Same workflow as I've previously used. Click on the import command and define the required placement geometry. In this case, I use the outer sheet metal face and the sketch point. To avoid confusion, I make unnecessary layers invisible. In the next step, I create a new 2D sketch and use the project DWG geometry command to make the imported underlay geometry available. The intention is to use the projected geometry in a face feature. I'm also going to mirror the strap to all sides to demonstrate the robustness of the DWG underlay associativity. Another nice opportunity to highlight the DWG underlay is the associative behavior of the DWG geometry. Maybe I repeat myself by highlighting this again, but I'd like to share my enthusiasm. So let's quickly measure the hole diameter of the created strap before we change the DWG geometry to have a closer look at the associative behavior. It is 3.6 mm. I switch to AutoCAD Mechanical now and change the diameter in the DWG file. Don't forget to save and switch back to Inventor again. Once a geometry update is outstanding, the local update command is active. Click on it and you get the latest geometry updates. I hope you could already see the hole got a bit smaller. Nevertheless, we measure the diameter again to double check if we got the correct value. Yes, 3 mm in diameter like in the DWG file. Back to the topic that the location of a DWG underlay associatively updates now. I enter sketch 1 and create the length of the rectangular smaller, just changing the values from 120 mm to 100 mm. Switching back to the model environment shows the referencing DWG geometry also changes its placement location. The DWG technology has also been enhanced to support the changing and re-establishing of the associative plane and the origin point. Previously, you had to import the DWG underlay again to change its plane and origin point. In Inventor 2017, you can simply use the redefine command to move the DWG underlay to a different associative plane and origin point, to reconnect the DWG underlay's plane or point of associativity if the dependent plane and origin point are deleted, to re-establish associativity with legacy files. The associativity that exists in a DWG underlay in an Inventor 2016 port or assembly file is not maintained when you open the file in Inventor 2017. Use the redefine command to re-establish the associativity. I'm going to cover the movement of a DWG underlay to a different associative plane and origin point. Sketch 3 contains two sketch points. One sketch point is already used to define the DWG underlay location of the strap. The other point is intended to function as a design change, as the strap should be moved to this point. Right-mouse-click on the DWG Underlay node in the model browser and selecting the Redefine command. You can easily define a new plane and point by clicking on the Wish geometry. Additionally, I'd like to demonstrate the robustness of the Change DWG Underlay location again. For that purpose, I change again the dimension of the rectangular. Back in the model environment, the straps change the location as expected. You can now easily reinsert the same DWG file into the port file. In previous Inventor versions, you had to walk the whole import way again to place an identical DWG underlay multiple times. With Inventor 2017, right-click on the DWG node in the browser and select Add Instance to place a DWG underlay another time. How does the workflow look like in practice? I use Sketch 3 with its two sketch points again to place a second instance of my strap geometry. Right-mouse-click on the DWG browser node and select the Add Instance command. The plane and point selection should be known now. You can now import step as reference model. Importing a step file as reference model maintains a link to the selected file, which enables you to monitor and update as the model changes. Before Inventor 2017, you could only import a step file without maintaining a reference. Following a quick look at the step import as reference model. A good example is to use a reference model in an assembly. If you work the first time with the place imported cat files command, you just need to make sure you import a step file with active reference model option. In the Select tab, you can limit the number of components should be imported in the assembly. If necessary, you can exclude unwanted components. In this example, I'm going to use all components in the step file. I also place two instances of the imported step file. As you can see in the model browser, reference models have a gray square around the assembly, respectively part icon. If required, you can edit the import by using the Edit Import command from the context menu. I decided to exclude a couple of components from the placed instances. Please note, the behavior of identical instances is the same as you would edit a referencing assembly or port file. In other words, if you edit one instance, the other instance gets the identical result. I quickly constrain both sheet metal containers to each other. Just to be complete, you can suppress and unsuppress the link to the reference step file if needed. Sometimes there is the requirement to break the link between the Inventor assembly and the reference step file. Please be aware that the reference model is converted then into single parts and single assemblies. So to say, the convert model behavior is applied after you've broken the link. Another enhancement. You can now specify a property overrides for CATIA, SolidWorks, NX, Pro-E and Creo files when the file is imported as a reference file by using the Place Imported CAD Files command into an assembly. Overwrite values entered in the iProperties dialog box display as blue. You can revert the value back to the original value using the new context menu option Value from Source. Overwrite values display in the bill of materials. As usual, a video for a better understanding how the new functionality works. I'm again in the assembly environment and take a Creo design this time to reference it into an Inventor assembly. Going into the eye properties of the reference model shows all model properties were mapped from the Creo to the Inventor assembly. I'm adding in the title property a name for the stapler assembly because it looks like the value wasn't filled in. As described on the previous slide, overwritten values are displayed as blue. Let's also have a look at the bill of materials to check what happens there with the properties. After enabling the appropriate BOM view, you can see the description value is already visible. The title eye property still needs to be added as column in the BOM view. If you would like to reset customize eye property values, you need to go into the eye properties dialog again and click in the value field. Right mouse click and select value from source displays the origin value again. In Inventor 2017 R2, you can now use the new Property Mapping for Imported CAD Data tool to easily map properties from CATIA, ProEngineer, Creo Parametric, NX, STEP, and SolidWorks to standard Inventor properties. The new Property Mapping tool replaces the manual effort of directly modifying the origin dataset in, for example, CATIA, ProEngineer, etc. There are three things you should know. Firstly, the Property Mapping for Imported CAD Data tool owns a separate shortcut in the Windows Start menu under the Inventor 2017 program folder, as well as runs independently from Inventor. Secondly, in the Property Mapping tool, the Inventor properties are located on the left side. Corresponding properties of supported CAD systems you can find on the right side. To set up a property mapping, for example from SolidWorks to Inventor, you should know the property names are used in SolidWorks. You can fill in the property names in the Property Mapping tool fields for the wished Inventor property mappings. The last thing you should be aware of is as soon as you press the Save button, a property map.xml file is updated with the changed information you provided in the Property Mapping tool. For each supported third-party CAD software is one XML file available. The XML files are located in C, Users, Public, Documents, Autodesk, Inventor 2017, Design Data, Import Properties by default. You're ready to import CAD files now. Your eye property will be filled in by the mapped third-party CAD properties now. There are significant improvements in working with mesh models. Following a quick overview what has been enhanced. You can import the RBG format into part or assembly documents now. You can also export solid, surface, mesh models to the RBG format. Further, create faces from mesh facets using the Fit Mesh Face command. Use the constraint and sample commands to create relationships between meshes and solids or surfaces. There's also the support to add work features using mesh as input for work planes, axes and points. Use the measure distance and angel commands with assorted mesh inputs. Load Express is supported as well. Import a step or GT assembly mesh and save the Inventor assembly and use the Express mode. Last but not least, visual styles are supported for mesh components as well. My personal feeling tells me the following question is one of the most asked questions. Why is it not possible to reference data from newer Inventor versions? There are substantial reasons for, like the data format changes from version to version, or a new feature has been introduced and isn't processable with older versions. Nevertheless, along with the Inventor 2017.4 update comes the capability that lets you work with others who are on Inventor 2018. For example, you can now reference an Inventor 2018 port file in Inventor 2017. Please note, you must have Inventor 2017.4 installed to support Inventor 2018 files. Alright, again a closer look at Inventor and the enhanced AnyCAD functionality. I think a quite often required use case is to reference datasets from newer Inventor versions in assemblies. There is no need to use an additional command. You can use the place component command. Focus on the displayed Inventor version, please. The dataset has been created in release 2018. Further, you can work with future datasets as usual. A look at the assembly browser shows you the particular AnyCAD icons. The gray square, which is framing the known part and assembly icons. Even the eye properties come from the newer Inventor datasets can be used. A look on the form dialog shows that. Only a short summary of the What's New in Inventor 2017 chapters. If you have taken the time to discover all of the 6 chapters, you should have a good overview of all relevant Inventor areas. I would love to hear your feedback about. Some recommendations from my side. The Inventor help page is always my first approach to understand a function, a workflow, etc. I also want to highlight to take the time and review the What's New help documentation, especially if you are interested in a special topic or small changes you need to know which could affect your user base. From time to time I need additional information, so I visit the resources in the red frame on the picture. Extremely useful is the Autodesk Knowledge Network. There are many contributions from our customers, Autodesk resellers, Autodesk employees, or enthusiastic Autodesk software users across the world. I strongly recommend to check out this site. Recently, I recognized an AKN search suggests Autodesk University classes as well. There are really good classes available. In the last resort, you have the Autodesk support loves to help you. That's it. Thank you very much and enjoy Inventor 2017.